In this video, we're going to explore one very popular theory for what computation or what algorithm the brain is running. I want you to imagine that you are a brain floating in a box of cerebrospinal fluid in a dark room. I want you to imagine that as that floating brain, you have no direct access to the world outside of the dark room, but you are interested in what's going on. The only connection you have to the outside world is the different electrical signals you receive that carry information about frequencies of light waves, sound waves, haptic vibrations, and chemicals in your immediate environment. As a biological brain, you also have limited resources. The brain uses approximately 20% of the body's energy in a normal day, but that energy is still finite. So you, as this biological brain floating around, have to be efficient with how you use your energy. The question is, what would you do in this situation? Maybe pause the video here and have a think. The system is always receiving new incoming signals. What's the most energy efficient way of dealing with those inputs? Arguably, the most efficient way to receive the incoming signals is to have a prediction about what those signals are going to be. That way, you only have to record the additional difference between what you predicted and what you actually experienced, what you received from reality. Imagine if you didn't have any prediction and at every new moment in time you had to represent the incoming message in full every time. That would be incredibly energy intensive and not to mention time consuming. Also, reality normally works in a way where what happened 1 second ago is tightly linked to what will happen in 1 second's time in the future. So if you had to regenerate the next image from scratch every time, you'd be wasting a lot of energy since the majority of information in the next image could have been predicted by what was in the image before. And from an evolutionary perspective, the system that is able to model changes in their environment faster will be more likely to avoid predators and kill prey. And the system that is able to model those environmental changes more efficiently will have more disposable energy available to use on new additional functions. The question then becomes, what does it mean to have a prediction about the world? About the world is like saying you have generated a model of the world. Although our subjective experience makes it feel as though we have direct access to the world, that we experience the outside world as it truly is, the reality is that our brain does not have direct access to the world. That thought experiment we began with, where that floating brain in a box in a dark room, that is a very extreme version of what your brain is kind of doing right now. It is just floating in cerebral spinal fluid inside our dark skull, and therefore it has to generate a model of the outside world. A brain isn't like a laptop or mobile phone where you can just download information directly onto a hard drive. It's sealed off from the outside world. We can't just stick a USB in our heads. So the only way we can be experiencing the outside world is because it's not technically the outside world. It's our brain's generative model of what the brain predicts the outside world is, given all of the information at that time and what's come before it. Okay, we have the prediction machine, we have the generative model, but now what? Piece of the puzzle is what this system is optimized to do. If the problem space is a 3D landscape with valleys and mountains, and the deepest valleys are the points of optimality, then what is this problem space optimizing for? What's its purpose or what's its objective? Remember, this is a biological system that is constrained by limited resources. It's fundamentally lazy and wants to do as much as possible with as little energy as possible. And we know that the system can't help itself but predicts the next moment at every time step, because that's the most energy efficient thing to do. Well, again, the most energy efficient thing for the brain to evolve to do is to minimize uncertainty in its world model. Remember the example of the tiger in the rainforest? In this example, the model hasn't predicted the tiger, and so there is additional energy that needs to be used to represent that error and pay attention to the approaching tiger. But let's imagine another person who has predicted the tiger. They are going to use less energy because there's no additional error to model, and they're more likely to survive because they predicted the tiger already. So, over time, evolution selects for brains that are better able to predict their environment. Brains that are better able to predict their environment are better at generating models of their world too. And better prediction means less surprise. So the theory goes that the brain's ultimate purpose, its fundamental algorithm that it's running all the time, is to reduce uncertainty, to minimize surprise. How the brain actually goes about doing this in practice is a whole other video. It involves something called optimal inference and active inference, and I will go into more depth about this in another video. To emphasize that this is one theory for how the brain works. Originally published by Carl Friston, this video has provided a summary of one part of the theory, and the main references for this theory can be found at the end of this video. The theory explains a lot of data across many fields, but it is only a theory, and there are many different ways the theory can be critiqued. If you have issues with this theory, like potential critiques, or you have feedback about anything that I might have missed, or ideas you want to see more of, then drop me a message in the comments below. Thanks very much for listening.